Next, let's do a new topic. The new topic is relationship between zeros and the coefficients of polynomials. We are going to discuss about the relationship between the zeros and the coefficients of a polynomial. First one is for a linear polynomial. What are linear polynomials? If the polynomial has degree 1, then it is known as the linear polynomial. We know that if k is a zero of a polynomial, p of x is equal to ax plus b, where a is not equal to 0, then p of k is equal to a into k plus b is equal to 0. Then the value of k is minus b by a. So the zeros of the linear polynomial ax plus b is minus b by a. Here minus b by a is equal to minus constant term. Here is the constant term and this one is the coefficient of x. So the zeros of the linear polynomial will be minus b by a. You must by heart this formula. For quadratic polynomial, in general, alpha and beta be the zeros of quadratic polynomial p of x is equal to ax square plus bx plus c, where this a must not be equal to 0. Then by factor theorem, this factor theorem has already been read in the class 9. Then by factor theorem, x minus alpha and x minus beta are both the factors of p of x. By factor theorem, we know that x minus alpha and x minus beta are the factors of p of x. Then we can write ax square plus bx plus c is equal to k whole into x minus alpha whole into x minus beta. So k whole into this multiplying, we get x square minus alpha plus beta whole x plus alpha beta, where k is some constant. So ax square plus bx plus c is equal to kx square minus k whole alpha plus beta x plus k into alpha beta. On comparing the coefficient of x square, x and the constant term from both sides, we get, on comparing these two, the coefficients we get k equal to a, kx x is equal to, here we get b is equal to k alpha plus beta and c is equal to k alpha beta. On comparing the coefficients of x square, x and the constant term from both sides, we get a is equal to k, b equal to minus k whole alpha plus beta and c is equal to k alpha beta. So dividing these two, we get b by a, which is equal to, the value of b is minus k whole alpha plus beta and value of a is k. Cancelling k, we get alpha plus beta, and multiplying minus on both sides, we get minus b by a. So here we already know that alpha and beta are the zeros of the quadratic polynomial. So you must know that the sum of zeros will give minus b by a. Minus b by a, which ax square plus bx plus c. Here this minus b by a is equal to minus, what is b here? B is the coefficient of x, and what is a here? A is the coefficient of x square. You must know it. You must by heart this one. What is the sum of zeros? Then you must definitely know that minus b by a. And if I divide this to 1, c and the a, c by a, we get the value of c is k alpha beta. So we write it, the value of a is k here, we write it, cancelling this to k, we get alpha beta is equal to c by a. So then you must know that the product of two zeros, that is the alpha into beta, we get c by a, which means that c is the constant term and a is the coefficient of x square. You must by heart this also. Okay, the sum of product is, let's revise it, sum of zeros is alpha plus beta, which gives minus b by a. Product of zeros, alpha beta, which gives c by a. Okay, next is the cubic polynomial. For cubic polynomial, there will be three zeros, that is alpha, beta and gamma. Let alpha, beta, gamma be the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, where a must not be equal to 0. Here sum of the zeros we give alpha plus beta plus gamma is equal to minus b by a. You must learn by heart it. For alpha into beta plus beta into gamma plus gamma into alpha, we get c by a, and for alpha into beta into gamma, we get minus d by a. You must learn by heart this one. Okay, let's revise it again. For quadratic polynomial, the sum of zeros will be minus b by a. For the product of zeros will be c by a. For cubic polynomial, the sum of zeros will be minus b by a, and alpha into beta plus beta into gamma plus gamma into alpha will be c by a, and the product of their zeros will be minus d by a. You must know this and by heart this one.